G'day guys, I've been asked to solve some fairly specific equations here for x and a and b. So what we have here is we have just a straight equation. Here we have a simultaneous equation that involves a and b, so solving for two variables. Basically in these two questions, they're testing our knowledge of index laws and how well we can apply them to, I guess these are sort of, you'd almost call them more curveball style index law questions, but as you're about to find out, if you know your index laws and have a fairly good working knowledge of them, then these shouldn't be too complicated for you. So to start with the top one, what we're going to do is we're going to make sure they're the same base. We're going to get the bases to become the same, and we're also going to get rid of this square root function here. So let's do that in one hit. So what we're going to do is for the first one, we're going to have 3 to the power of 2x plus 4 to the power of a half. So that's an index law that we have there, and that's going to be equal to 3 to the power of 3, which is 27, to the power of x. Now what we do is we use the distributive law here. We're going to multiply into the bracket, so we're going to be left with 3 to the power of 2 to x times a half is just x, plus 4 times a half is 2. And we have 3 times x is 3x. Cool. So now we have the bases that are the same. This is quite simple from here. What we're going to do is if this is equal to this and the bases are the same, it means the powers have to be equal to each other. So basically what we can then do is we can say, well, therefore x plus 2 has to be equal to 3x. So what we're going to do is I'm going to take the x over to the other side. 2 is equal to 3x take x is 2x. So naturally, x is going to have to be equal to 1. So not too complicated. As I said, if you have a working knowledge of your index laws, you should be able to solve that out no problems. The next one here, I imagine kids will get, or whoever's trying to attempt this sort of style question are going to get a little bit bamboozled by the fact that we have two different variables we have to solve for using index laws. But as you're about to find out, this is no different to this one and is no different to a very, very basic simultaneous equation question. So what we're going to do first is we're going to make the bases the same. Again, you can see like a ongoing pattern here. So we're going to be able to rewrite the first one as 2 to the power of a plus b is equal to 2 squared. And we have 3 to the 5a minus 2b, that's supposed to be a 2, is equal to 3 to the power of 3. Now, what this is going to allow us to do is, again, like we had in the first equation that we had to solve, if the bases are the same and they're equal to each other, that means that the powers have to be just equal to each other. So what this is going to yield is we're going to have a plus b equals 2. And in this one, we're going to have 5a minus 2b equals 3. Cool. So we can rearrange the top one to make it equal to, make b equal to 2 minus a. And from there, we're going to substitute that in for b in the second equation. Cool. So that, therefore, we're going to have, if we substitute b into the second equation, we're going to have 5a minus 2b, which we've worked out as 2 minus a, equals 3. We can multiply out that bracket. And from here, we're going to combine our like terms, and I'm going to move the 4 over to the other side in the same hit. So I'm going to plus 4 to the other side, and I'm going to combine my a's together. So I'm going to have 5a plus, so if I combine them, it's going to be 7a equals 3 plus 4 is 7. So therefore A is equal to 1. Now if I substitute A into the equation, I'm to find B. So I'm going to write, well, B is equal to 2 minus A, which is 1. So B is also equal to 1. So you can see there that once we make the bases the same and we're able to just equate the indexes with each other, it turns into quite a simple simultaneous equation. And I use the substitution method because that's the one that I feel the most comfortable with. So let's just run through all this again. So what we had here in the top one is we had two equations. The first thing I like to do is I like to get rid of the surd by replacing it with something to a fractional power. And I also like to make, if I can, try and make the bases the same. So in this case, it was quite easy to see that 27 is 3 cubed. So it was easy to make the bases the same. Once I've done that, using a couple of index laws, like we have the distributive law, and also the fact that if we have a bracket to a power, the powers are multiplied. So once we're able to do that, we're able to simplify it out to here. We're able to get rid of the bases, equate the powers, and then solve for x. So not too complicated. And we basically did exactly the same here. We converted each of the numbers on the right-hand side of the equals sign to the same basis as the number on the left-hand side. Once we did that, once the bases are the same, we can equate the powers, and that's what we did. And then I used the substitution method. You guys could use the elimination method if you feel like it to solve for A and B. So it's not too complicated, guys. These sort of curveball questions, if you don't practice them very much, in an exam, I can imagine that these would throw off a lot of different students just because they'll look at a question, especially this one, which is actually quite simple. But if you haven't seen a simultaneous equation in index form before, it could freak out a couple of kids, I reckon. So make sure you practice them. Make sure you see all these different permutations of index law questions. If you have any troubles with any of them, just give me a holler. You know, I like to solve problems and I like to help you guys out. And I'll be more than happy to help. If this video helped, give it a like, subscribe to my channel, and I'll see you guys again next time.